Hello, my wonderful student and students. You're here watching us going over the blue AP Day 11 homework. The purpose of this is to help you figure out exactly what to do and what to look for in the future. Now, right now, I put a timestamp in. You can actually fast forward to whatever problem you want to do from this. All right? So we're starting with problem number 1. And here we go. A motorboat is... Ooh, can we see that color? We can see that color.
That's a little...
We can barely see that color. Randall's my main man behind the camera. He says we can't see it. We always trust him. A motorboat is traveling 4 meters per second east. 4 meters per second, that's the east direction. And encounters a current going to the north, 3 meters per second. So I'm going to draw the river banks like this. And this is the boat, and that is the current. Question A says, what is the resultant velocity of the motorboat? So the resultant is that x, y are both combined. And we're going to say both combined. So the motorboat is going 4 in the x, and the current is going 3 in the y. And together they make this overall velocity at some angle. Now, this always makes a right triangle, which is why we can use the Pythagorean theorem all the damn time. So if I do the Pythagorean theorem, I end up with 5, ooh, wrong color, because that's the x. I end up with, wrong color again, I'm awesome at this, 5 meters per second is my overall. And that's just 3 squared plus 4 squared equals the square root of v. So anytime you see the phrase resultant, we use the Pythagorean theorem of our x and y values, because resultant means overall. Then it says, what angle is the boat traveling at? Well, I could use any number of equations to find that, either sine, cosine, or tangent. I personally just use tangent. Tangent of the angle is to be opposite over adjacent. And I got 37 degrees. Now remember, vectors always need a direction and a magnitude. This is the magnitude. This is the direction. It's not positive or negative because it's kind of a resultant. So the resultant is never positive or negative. It's always either at an angle. Now, letter C, we're going to go back over here now, says if the width is 80 meters, so now you have 80 meters, and that width, is that the x, the y, or the overall? What do you say, director?
X.
X, great. And since x and y don't affect each other, if I have an x displacement, I'm going to use only the x part of the overall. And the x part of the overall is that 4. Now there's no acceleration
Nash,
here.
please call the front office. Mr. Nash.
We got all kinds of beautiful things in here, but if there's no acceleration, then we could use this. Velocity is displacement over time. And plugging in, I find the time to travel across is going to be, 20 seconds. And then for letter D, it says how far downstream. Downstream is kind of like this distance. Is that the x, the y, or the overall, Mr. Director?
That's the Y.
Randall said y, of course, is correct, like always. And since we know the time, this time is the time both in x and y. We could use that time with the y velocity to find that y displacement. And you get 20 times 3 is 60 meters. If I wanted to find the overall displacement, I have 2 ways. I can either do the Pythagorean theorem, again of the x and y parts, or I can do the overall time times the overall velocity and get an overall value. 2 ways. And now let's go to number 2. Now let's number 2. In number 2 it says an acceleration of 0.004 meters per second squared positive. Does that mean you're speeding up? And the answer is, of course, not necessarily. The reason being, this is a positive acceleration. That means you gain that much every moment. if you're going at some positive velocity, for example, positive 1 meter per second, a second later you're now going 1.004. So that makes you go faster. The corollary, however, is if you're going negative 1, and this is your acceleration, you're now at negative 0.996 meters per second. You've gotten slower. Positive accelerations mean a positive velocity increases, but a negative velocity decreases. And that is something that you should know. And hey, let's do number 3 together. In number 3, we have a situation. We have got something starting at 0, at position 0. And then 30 meters later, you end at rest. Ooh, I'm sorry. We don't know our initial velocity. My apologies. We're going to see how fast they're going and if they broke Baltimore's 90 kilometer per hour speed limit. Well, this gives us meters in seconds. This is in kilometers per hour. I'm going to convert this. 90 kilometers per hour. 1 kilometer is 1,000 meters. 1 hour is 3600 seconds. And 90 kilometers per hour is equivalent to, 25 meters per second, which is actually my favorite number. So what I'm going to do is I'm going to figure out how fast this person was going compared to 25. If this person was going faster than that, broke the law. If they were going slower than that, they did not break the law. And now it's just basic application. What's the acceleration? I know it's negative 15 meters per second squared brakes. And I get V naught is 30 if you do the math. Obviously it's speeding. So here's the main point. In this situation, if you are given and you're trying to compare it to a value, then you want to find what that value is using the information, and then take that value you found and compare it afterward to that point. Don't assume this is the velocity. Just find what it is and compare it to that value. And now, in a moment, let's go to question number 4. And now it's time for question number 4. My, has time grown? We have 2 pandas. They're running off a cliff in the throes of love. The female moves forward horizontally with some number as her initial velocity. The guy just drops. Question A says, how does her time compare? Here's how I want you thinking about it. In the y direction, which is the time it takes to drop, because gravity's pulling them down. So to find the time it takes to drop, it's always about the y. Their initial velocities are the same. The female is going forward. She has no initial velocity. The male has no initial velocity either. They have the same acceleration, negative 10, and they have the same falling displacement. So they better have the same time. You remember this because we actually had a scenario out in the hallway where we threw 2 balls, and one was shot forward, one dropped, and they hit at the exact same time. But the next question is, how do their velocities compare when they hit? And the answer is, they're different. The female is definitely faster. If you were to solve for the final velocity in the y, they would also be the same. But what is different is the x velocity. The male has none. The female, though, has some. It says female, by the way.
Okay.
I know. So, if the female has got a velocity, when they hit, the male velocity picture looks like this. The female's has the same velocity in the y, but she has the added velocity in her x, which results in a larger overall velocity than the male's. Thus, she hits with a faster velocity. For letter C, how does the y displacement compare? Well, once again, it's the same. They both start at the same height. They both end down here in the y. Got to be the same. The letter D is the overall displacement. We use the same picture. The male's overall displacement is just the y. The female's is that y and x resultant. Which, in order to find that result, you must use the Pythagorean theorem. Displacement squared. Since to find the result from something at an angle, you must use the x and y parts. So the female traveled more meters because she ended up further from the start in the x and the same amount in the y. So in this case, the female wins. Let's try the last one now. All right, and now it's time for number 5. This one's the one you're sure you've been waiting for. So it says to draw a picture first. I'm going to do that. Here's my number line. It's nice and pretty, just like you are.
Are you
I
sure?
start off, I am sure. The initial velocity at 37 degrees. This is a x position of 0. Here at 50 meters, there is a 3 meter tall tree. So this point is 3 meters. Then here at 60 meters, it hits. And it takes 3 seconds to hit. So I'm going to do something like that. That's my picture. That was part A. Part B says find the overall initial velocity. Now, overall, is that the x, the y, or them combined? And the answer is them combined. So what we're going to do is we're going to make our information of x and y. Let's look at x first. I don't care about this tree quite yet because that's not part of the overall motion. The starting position is 0. The final position is 60. The time is 3 seconds. There is some kind of initial velocity we can find. And the acceleration is 0. Quick note, this is not the same as the overall initial velocity because it's initial velocity in the x. So it's that kind of part right there. And now the y. Let's use a different color for y. I should have used pink for this, but whatever. Let's use...
Not the red.
Not the red, don't worry. Orange. Because that's y too.
Okay, good choice.
Thank you. The starting position, height-wise, is 0. The final position, height-wise, is 0. The time is still 3 seconds overall. Initial velocity we don't know. And the acceleration is negative 10 meters per second squared. We're going to solve initial velocity from both of them. The reason being, once we have the x and y's, just like in the other parts, we can find the overall from that. So now, I just had a little bit of fun. I use the same equation 2 times. And you just assume, if you do it, that you get the initial velocity of 20 in the x, positive, meters per second, and 15 in the y, positive. You knew it had to be true that this was less, because at 37 degrees it's less than 45. You have more forward than up. Now, the whole point of doing that was to find the overall, since it's the result, because it's at an angle. The result is always the combination of the x and y's through the Pythagorean theorem. And you'll get the overall velocity to be around 25 meters per second. Not positive, not negative. It's that at the angle of 37 degrees. And now let's look at part C. We have to figure out how high was it when it crossed over the tree. Now, take a look at this. Is all this information correct here? And the answer is going to be no. The time is no longer 3 seconds. It is no longer 60 meters away. We're looking at just this part of the relationship. So above it, I'm going to make the information I know. Starting with x. The starting x position is still 0. The final x position in this new case is going to be 50 meters. The acceleration is still 0. The time is no longer 3, but the initial velocity in the x is always that 20. That's still the first part. In the y, the starting y position is still 0. The final y position we're trying to find. It's not 3. We can't assume it just barely grazes it. We're going to find what it is. The acceleration is still -10. The initial velocity is still 15. But that's not enough information. We need something else. And the one thing that's true for both x and y is going to be that time. So you can see what's going to happen. We're going to use the x information to find the time it takes to go that far, and we'll use that time to find out how high. Choosing the right equation, the same one as before, I believe. Yeah, the same one as before. We're going to use this. You're going to find the time to be 2.5 seconds. We're going to use that time to find the y final position. Using the exact same equation, so we've used this 4 times now. It's pretty dang important. We're going to find the y final position to be 6.25 meters. That is not how high above. That's the total height, because it's measured from the ground. If you wanted to find out how high it was going to go, you would take this number, subtracting this 3, and find that value. And with that, my wonderful students, we have just used part and whole of the entire arc to find what we needed. You should have used the idea of the resultant all throughout this homework. And I hope you have a great day. Thanks.